Hello everyone, welcome back. This is Calculus 3. In this video, we are going to talk about the new chapter 2, 2.1 vectors in the plane. So I'm going to introduce how to describe vector, what they mean, and how to perform basic vector operations, and introduce a couple terminology around vector so that we can build up the basic concept of the three-dimensional space. Okay, so let's take a look at the information about vector. So maybe you heard about vector in the previous math courses. So what is a vector? So vector is a quantity, okay? So this is a quantity such as a velocity or force. You may heard about, maybe you may hear about vector in many physics concept, but we're going to talk about vector more mathematically, okay? So vector means in math, it contains two important components. One is a magnitude, second is a direction. So in the space, it could be a two-dimensional space or three-dimensional space. You are going to point out, let's say this is the position that we are trying to reach out. We call this is the terminal point. And then this is your initial point. So you start from here and you're trying to get this at terminal points. And then we can describe this information as a vector system because vector, what did I say? It has a magnitude and direction. So to get here, you can talk about the distance, that's the magnitude. And then to get here, you can describe it, this is the between, north and east way. So vector, this is the concept, used in many different fields, but we're going to focus on, vector in mathematical word. So make sure that vector contains magnitude and direction, and we are going to write vector. If you find out the vector system, we call x1 and x2, we call this as a component of A. Okay, so the following statements are a couple characteristic of vector. So sounds like a little bit abstract, but let me I actually wrote down all the characteristics for your better understanding about vector. So first is a representation of a vector, remember, is an arrow. So we are going to describe vector as an arrow symbol. And then it means you beginning from the initial and you're trying to get where? Terminal points. So there's initial and terminal point, and I'm using the arrow symbol because this indicates the direction. Second, the length of the arrow, we call the length of the arrow, it is going to be, we call magnitude of the vector. And then as I just described, this arrow means direction of a vector. So magnitude, direction, this is important components of the vector system. So magnitude and direction. And then third, the component A1, A2 indicate how much the vector acts in the positive X and Y. So the A1 is it came from the X-axis. A2 is it came from the Y-axis. So let's say I have a vector 2, let's say 3,3 or 3,2. You are going to 3 unit on the x-axis. It's a similar, that you're reading the coordinate points. Your 3 is a unit on the x-axis, and then 2 is a unit from the y-axis, and then 3,2 exactly at this point you have a magnitude, right? And you have a direction. So this is the component. These are the component of vector A. So that's how you read it, okay? And then the last one, if you start from the 0, 0, we call that as a position vector. This is a 0, 0. So vector, can be a variety of forms. So if you have a space, you can have a vector here, from here to there, or you could have from here to there, or you could have an opposite direction. So you can describe vector by using the component A1 and A2, And then it could be a variety form, right? So it could be here or it could be short. So this is the basic concept of the vector. It's not really complicated at all. So vector, we're going to use as a number quantity, and then it implies that, oh, there is a magnitude length and there is a direction. And then these are all the characteristics you can think about, vector. Okay, so that's the just basic concept of the vector. So we're going to keep building the concept on vector system. And let me just go down slowly. I'm going to develop the concept more. So let's talk about vector between 2 points. So as you know, vector, we have initial points, right? Initial point, and we have a terminal point. So in the two-dimensional space, you might have x1, y1 as an initial point, and you have x2, y2 as a terminal point. So how to describe the vector between these two initial and terminal points? So let's say this is point A, and let's say this is a point B. So A is basically x1, y1. B is x2, y2. So therefore, I can rewrite, right, the vector AB. So that's how we're writing. Vector AB is x2 minus x1. It's not slope. When you think about slope, it's x2, y over x. But here we are going to write as a horizontally. So x2, x1, and y2 minus y1. This is a vector from A to B. That's how you read it. Okay, so the AB, so this is the vector we just talked about. The vector AB is going to be the difference on x-axis, comma, the difference on y-axis. That's how you're going to find out the vector between 2 points. So let's take a look at the example. So the vector is not really complicated concept. We can think about it, in an efficient way. So example 1, find the vector. So I'm going to find out the vector by the directed line segment with the initial point is a given, 4, 1. And then I'm going to point out 1, 2, 3, 4, 1. This is a 4, 1. And I have a terminal point, 1, 2. So where to where? This is going to be the initial. This is going to be the terminal. So this is the vector AB. Am I correct? They want you to find out the AB vector. So the vector AB, which means from A to B, we are going to subtract x2 minus x1, comma, y2 minus y1. So x1 is going to be 4. X2 is going to be 1. So 1 minus 4, comma, 2 minus negative 1. So there, it's going to be negative 3, 3. So this is going to be the AB vector. And then let me just write down negative 3, 3 right there. Negative 3, positive 3. So this is going to be negative 3, 3. So I'm going to start from, because this is the AB, we're going to start from the, origin point. So if I draw that point, what do you guys think? These two vectors are parallel line. Okay, so this is actually AB vector, right? From A to B, we found out the vector AB. When I draw the AB vector, it's negative 3 and 3. That means from the 0.0 to negative 3 to 3, they are going to be always parallel line because they are corresponding to each other. We call that as corresponding position vector. So there are many characteristics we're going to discover here. So this is something you can think about. Okay, what is a vector's definition? There's a magnitude, there's a direction, and then you can think about, what is the, vector between 2 points? We can actually calculate it. And then the vector between A and B and AB vector, they're going to be parallel line. So not really complicated. We can definitely understand. This is basic concept of the vector. So we're going to keep going. Now I really want to measure the magnitude. So what is the magnitude? This is the length. So whenever you have a vector, right, I want to find out this length. How to do that? Here's a formula. So to find out the magnitude, that means the length. So you have a vector, let's say A. So the A1, A2. So A1, we have A2. So this is going to be A vector, A1, A2. I want to find out this length, the magnitude, correct? So the formula is going to be this. You are going to square of each component and then summation and put the radical. That is going to be the magnitude, the length of the vector A. Okay, so I'm going to show you the example. And the one thing is, there's a zero vector. No matter what you multiply with the zero vector, whatever the vector is going to be, zero. So we can also talk about the operation of the vector. Just be aware, zero vector means 0, 0. Okay. Another thing, so this is the magnitude formula, zero vector, and then the third one, I want to introduce scalar multiplication. So you might see, so let's say I have a vector V, right? And then let's say this is a V1 and V2, this is a vector. What does it mean 2V? You are going to multiply 2 of each component. So this is going to be 2B. Am I correct? So let's compare the size, the length of the V and 2V. What do you guys think? The V is this amount. 2B is going to be double. So what we can do, if you multiply scalar, let's say C is a scalar. C, if you multiply C, that is greater than 1, it is going to be, the vector is going to be always a stretch. So if you have a 3, it's going to be triple stretch. If you have 2, it's a double stretch, correct? And then you can actually make it shorter. So here, the second one, if you multiply 1 over 2, we know V equal to this length. But if you multiply half, it's going to be shorter. So therefore, if scalar is between 0 and 1, the vector is going to be shrink. It's going to be shorter. Does it make sense? Last one, if you multiply the negative number, you see that? What do you guys think? The direction is going to be the opposite. So we know that V is going to be the, this direction, but now you have negative V, it's going to be opposite direction. So the last one depends on the size of scalar. If C is a negative, we're going to find out opposite direction. So this is all the characteristic we are keep talking about. Does it make sense to you? So in this slide, we are going to see how to find out the magnitude, the length. This is the formula. And then just be aware, zero vector means a 0, 0. And then depending on the size of the scalar, the length is going to be changing. So scalar is causing factor of changing magnitude of a vector. Does it make sense? So specifically, if you multiply the number that is greater than 1, the length is going to be stretched. If your scalar is between 0 and 1, your length is going to be shorter. And if you multiply negative number, the direction is, the length is going to be the same, but the direction of the vector is going to be opposite. So check this characteristic, okay? So exactly the next slide, I'm talking about the same thing right there. Okay, so if you multiply scalar, all right, you're gonna have a different, size of the length. So I'm gonna copy this and then paste it here one more time. So this is exactly what we just found out. And then let's think about the adding and subtracting. So in this slide, we are talking about the multiplication part, addition and subtraction part. What if you adding and subtract or multiply the vectors? So this is operation of the vector. So multiply, adding, and subtract. What if you adding and if you have a two different vector, A and B, what if you're adding, multiplying, or subtract? So the scalar we just check, right? And then the vector addition. You can adding two different vector. So if you're adding two different vector, A and B, you can simply adding X component, and then you can adding the B component. So you can find out the A plus B vector. But here is the thing, right? Here is the thing. So what I'm gonna do, let's imagine the vector. So I do have a vector. This is the vector A, looks like this. And let's say I have a vector B, looks like that. Let's adding them. Okay, let's adding them. Let's see what happened. So A is going to be here. And B, if I'm adding here, so this is A vector. And then this is the V vector. The summation is going to be here. So this is going to be the summation, A vector plus a V vector. What kind of shape do you guys see? This looks like a triangle. So if you're adding two vector, you will find out the triangle shape. Does it make sense? And then another thing you can think about, I do have a vector A here. I have a vector B here in this time. And then the summation, it's going to be longer. And then it's going to be between here. This is A vector plus a B vector. Ooh, what do you guys see? In this time, we have a parallelogram. This is the parallelogram shape. So if you're adding two vectors, you will find out either triangle or a parallelogram. So that's the characteristic when you're operating two vectors in terms of the addition, okay? So I'm talking about addition and multiplication so far. Let's think about the subtraction. What do you guys think? So if you subtract, right, vector, so you are going to adding, so this is the vector A X component, and this is the vector B's X component. You're going to subtract each other, X's and Y's. And then what does it mean? Like in the graph or in the image. So the vector subtraction, so I'm going to highlight it. So think about the same idea. I do have a vector A, and I have a vector B, looks like this. And I do subtract. So subtract means you have a negative, so A vector minus B vector. You multiply -1 times B vector. So minus B vector, it's going to be opposite, correct? So therefore, you can combine these two. And then what do you guys find out? So we do have A vector. And then I do have a B vector, right? So that A minus B vector, it's going to be shorter. It's going to be shorter length, which is here. So A vector minus B vector, you will find out most likely a triangle shape. Okay, so that's a characteristic of operating two vectors, either multiplication, addition, and subtraction. So that's all about, a characteristic about the basic vector concept. So think about it. You can stop the video and go over, everything we talk about it. So I'm going to go up a little bit. We talk about the definition of the vector, and then, vector contains magnitude and direction, couple characteristics. And then we talk about, one thing, parallel line, when you're, finding out the vector AB between 2 points. And then you can actually find out the magnitude, the scalar, multiplication, addition, subtraction when you're operating the vectors. So let's do a couple work. So that's a basic concept. Here we go. All right, let's find out the answer for A 1, 2, 3, 4. The two vectors are given. The vector A is a given. Vector B is a given. The first one, what does it mean? This symbol means find the magnitude. They're asking you, hey, find out the length of vector A. So we have vector A right there, 2 comma negative 1. So it's always going beginning from the 0, 0.0. So they are looking for this length. So this is vector A, 2 comma negative 1. So according to the formula, you are going to square of each component, right? Or you can rewrite it. You're going to, so let me write it. A1, the first one square, A2 second, so we can plugging in 2 square plus 1 square, that is going to be radical 5. So this is the length of this magnitude. Okay. All right, so that's fine. So let's do letter 2, number 2, A vector plus 2 vectors. So we have A vector, 2, and then you're adding B, so 2 plus 6 minus 1 plus 7. So it is going to be 8,6. This is the summation. Okay. Subtraction, simple. 2 minus 6, negative 1, negative 7. You're going to find out negative 4, negative 8. This is the subtraction. And then this is a scalar. Everything is greater than 1. So it's going to be stretched a lot. So 3 times 2, negative 1 plus 4 times 6 and 7. So 6, negative 3 plus 24, 28. You will get 30, 25. So this is 8. So these are all the operation of the vectors, summation, subtraction, and multiplication length. So very, very, basic concept. You can also draw the image and check it out, whether you're going to find out the triangle or parallelogram. Okay. So now I'm going to show you more properties of vector operation. Let's take a look at it. So there are a couple things, you can change the order. So vector u times v is the same as a v times u. That is a commutative property we call. And then if you have a 3 vector, you can change the order as long as everything is addition. We call that as associate property. No matter what you're adding 0, it's always yourself. If you subtract the opposite, it is going back to 0. If you have a multiplication, you can also change the order. And the distributive property, same algebraic property apply in the vector operation as well. So just I want to make sure these are the properties of vector operation. So that's the so far basic vector. Now I'm going to talk about the next concept, a little bit different type of vector. I'm going to introduce a unit vector. So let's take a look at it. So we need to, in calculus 3, there are many new terminology of mathematical concepts. So whenever you see new terminology, please be aware what they mean exactly. So for example, unit vector has a specific definition. It is a vector, but it has a magnitude always 1. So if your magnitude of the vector is 1, we call that as a unit vector. That's how we call it. Okay, so for example, I have a vector A. So this is a vector A. It's a longer. I want to find out the unit vector of this vector A. So what does it mean? We are not sure. The magnitude of A. It looks like 3,2. So vector A looks like a 3,2. And then if you calculate the magnitude of the vector, it's not going to be 1. It's going to be some number. I want to find out a little bit. It's a subset. Unit vector, you can think about the subset of the vector. I want to find out the unit vector that only gives you the length is 1. Because the definition of the unit vector, the magnitude is 1. So the unit vector is a part of the another vector, but their length is going to be just 1. Okay, so those are 2 vector. One is a unit vector and original vector A. They always have the same direction. That's why. Does it make sense? So whenever you could have this length of the vector V You can have a long vector W, or you have a vector T. Every vector has a unit vector because a unit vector is a subset. Specifically, the length is 1. So this one length could be 2. This one length could be 5. I don't know, right? But I just want to find out the unit vector that gives you only length is 1 because that's a subset. So the unit vector, we're going to talk about more, but unit vector, you can find out by using the following definition. So unit vector, you have a given vector and then divided by its magnitude. Okay, so if you use that, you can find out the unit vector. So let's take a look at the example. So this is exactly the example. I want to find out the unit vector that is the same direction as a vector. So a vector, if you draw that, 1, 2, 3, 1, 2, 3, 4, 5. So this is the a vector, 3, -5. So this is the direction, and that's the length. I want to find out the unit vector. So unit vector is going to be somewhere here, and the length is going to be exactly 1. How to find that? So unit vector is you have a given a vector divided by the magnitude of the a vector. So the a vector is a 3, -5 divided by, how to find out the magnitude of a? 3 square plus -5 square with the radical. So we're going to calculate 3 -5 over, this is a 9 plus 25, 3 -5, this is a 34. So unit vector, we found it. One is 3 over radical 34. Another one is -5 over radical 34. So this is a very tiny vector, which is here. So this is a unit vector that gives you the length 1 out of the vector A. That's what they mean. Okay, so be aware. Unit vector is a hidden. Okay, because the length is always 1. So whenever you have a vector, yeah, your unit vector, it could be the same direction, but it's going to be shorter because the length is 1. So think about it. Unit vector is very, very unique because later we're going to use this a lot. So take a look at this formula. So this is a whole. You are looking for only the unit vector that is which the magnitude is 1. Okay, so that's how you're going to find out the unit vector. All right, so same thing. I'm going to keep going over and over and again. So let's take a look at the following question. Okay, 2 example. Find the unit vector. So one more time, practice. I want to find out the unit vector. So in this graph, we have 1, 2. So this is a vector V. And I want to find out the unit vector somewhere here, same direction. So unit vector, you're going to have a V vector divided by its magnitude. So 1, 2 divided by 1 square plus 2 square. 1, 2, it is going to be 5. So therefore, unit vector, we found out 1 over radical 5, 2 over radical 5. So this is a unit vector right there. And then the length is going to be 1. So we got letter A. Let's go to B. Find the vector U with the same direction as V such that W magnitude is 7. So there are 2 vectors. So let's think about it. First of all, we know, so we have U and V, okay? And there is a W, okay? So we're going to find the vector U with the same direction as V. So we already know what the vector U. We already found it, 1 over radical 5, 2 over radical 5. And then it has the same direction as a V. Okay, that's correct. But this time, the V is actually, it's the same as a magnitude W equal to 7. So what does it mean? So let me write it first. The vector U is the same direction, correct, as V, and we know the magnitude of U is going to be 1. That's the definition of the unit vector. So there is a W, right? So W is this, another vector, and then it has a 7. So what does it mean? Use scalar multiplication to increase the length of U without changing direction. Think about it. There's another vector W, but this is also has the same direction, as a U, right? So that's a very complicated, sentence, but the meaning is you have to find out the vector W, actually, I have a little bit of typo. So let me change this question a little bit, sorry. Let's find out the vector W, okay? So this is much clearer. So we want to find out, so let me just rewrite it. I want to know what the W vector, okay? And then this W vector has the same direction as a W. And then, the magnitude of the W vector is a 7. So now it's clear. So the vector U is the same direction as a V. So magnitude of the U is 1. So use a scalar multiplication to increase the length of U without changing direction. So what I'm saying is W is going to be 7 times U, right? So therefore, this is a 7 times. We multiply the magnitude. So 7 over radical 5, 14 over radical 5. So think about it. We are looking for the vector W, and the magnitude is a given. This is a 7 times longer than unit vector. So therefore, I can set it up. W is equal to 7 times U, and then I need to change the question a little bit. Sorry about that. This one should be U. That's better now, right? So same direction. So now this makes sense. W is a 7 times of U vector, right? And the U and W are same direction. So we can set it up this relationship, correct? So we already know what the U, you just multiply 7. So you can find out the W vector, which is this answer. So my question was a little bit awkward at the beginning. So I just changed the wording. So now you can see, how to find out the W vector because they say same direction. That's a hint, okay? So the U and W, it's the same direction, and the magnitude of 7 is already given. Magnitude of the W is a 7, magnitude of U is 1. So they have a 7 times a relationship. You multiply 7 of U, so you will get W. So therefore, W is gonna be that answer, okay? So that's the concept of the unit vector, okay? So I hope you understand what that means, unit vector. It's kind of like a subset, and it's a very, very, fundamental thing of any vector system. So now I'm going to introduce the next one, standard basis of unit vector. So what is a standard basis of unit vector? First of all, we have a vector A. Let's say it is A1, A2. So when you look at the image, this is the vector A. You have A1. You have A2. So this is the vector A. And then let's think about it. What if I have A1 is, this one is 1. You go to 1 units on the x-axis. You go to 1 units on the y-axis, right? So let's see that. Now this image. So we have A1 equal to 1. A2 equal to 1 as well. Am I correct? So therefore, A vector, you can say A1 times 1, 0 plus A2 times 0, 1. Because it is A1, you're going to do the distributive property A1, 0 plus 0, A2. Gotcha. It's A1, A2, same thing, we got it. So we call this number, you see that 1, 0, 0, 1 in each x and y respectively. We call this as a standard basis vector because no matter what you multiply, 1 is yourself. No matter what you multiply 1 on the x-axis, y-axis, it's always yourself. So therefore, vector A is A1, A2. You can also write it using standard basis vector A1I plus A2J. So I is 1, 0 vector. J is a 0, 1. We call these I and J are standard basis vectors. Does it make sense to you? Okay, so I'm gonna write it. Standard basis vector is I 1, 0 on x-axis. J is a 0, 1. So these are very, very fundamental, units of the unit vector. Okay, because the length is going to be always 1 of this standard basis vector. So that's another way you can write down the vector system. So depending on the textbook, some textbooks say, hey, A vector is A1 and A2. Sometimes you can write it, A vector is the same as A1 times I times A2 times J using the standard basis vector. So therefore, let's take a look at the example. So now this is the question exactly. Find the unit vector, right? And then this is the vector V. So what does it mean? Vector 2I plus 3J means 2 times 1, 0 plus 3 times 0, 1. Because 1 and 0, 0 and 1, they are standard basis vector. So 2, 0 plus 0, 3. So V vector exactly 3, 3, 2, 3. So if you're reading just coefficient, that's going to be your vector. Now we are looking for the unit vector. So I'm going to make a space. They're looking for the unit vector of vector V. So unit vector is a V vector divided by that magnitude. So we have a V vector divided by magnitude. 2 squared, 3 squared, so 2, 3. 4 plus 9, so 2, and 3, 13. So basically, it is going to be 2 radical 13, 3 radical 13. This is the vector U. Also, you can rewrite the U vector how? Same as 2 radical 13I plus 3 radical 13J. They're same answer. Does it make sense? So you can think about standard basis vector and how they apply in many different vector systems. Okay, so far so good. So I'm showing you many mini concepts in 2.1 around vector. So not only just the characteristic of the vector system, you can think about the property of vectors and how to operate them and what the unit vectors are. Check it out. Okay, I'm going to introduce one more mini concept in terms of the vector system. Let's take a look at the next slide. Component form of a vector. So this is a very, very similar work what we did in chapter 1. So we just same idea. We have vector A. Let's say this is A1, oopsie, A1, A2. So we know that A1 is on the x-axis unit, A2 is the y-axis unit. So think about it. Do you remember the polar coordinate system we talked about in chapter 1? X, y, you can convert it to r, theta. They're located exactly the same position. So same thing, I can convert the vector A in terms of the polar coordinate system. If you find out that vector, we call that as a component form related to r, theta, polar coordinate system. Does it make sense? So we are going to convert x comma y in terms of r comma theta to, indicate the location of a vector. Does it make sense to you? So if you remember, r is a radius. So this is going to be the r. Magnitude is going to be r, right? And theta is going to be the angle between the vector and x-axis. So according to the Pythagorean theorem, we prove that if you go to recall chapter 1, polar, I think 1.3 and 1.4, we prove that x is equal to radius times the cosine theta, y is equal to r times the sine theta. Am I correct? So therefore, this is x, this is y. Vector A is the same as r times x is a cosine theta, y is r times the sine theta. We can convert this regular vector system into the polar coordinate system. We call this vector is a component vector system. Just name. Okay. So therefore, component form of a vector A is going to be, this is x, this is y. In other words, this is x comma y, this is A1, this is A2. Got it? So nothing is memorized. You don't need to memorize anything. Just think about it. Oh, we know how to convert x comma y rectangular coordinate system to the polar coordinate system. Same thing happening in the vector system. Just vector, it's another language that contains, magnitude and direction. But, this is the position exactly based on x-axis and y-axis. I can convert it to the polar based on r, radius, and theta angle. So therefore, vector A can be also representative r comma cosine theta and r comma sine, r times the sine theta. So let's look at the example 5. So number 5, find the component of a vector A. The magnitude is 4 and forms an angle. They create the angle 60. And then this is a counterclockwise, find out the vector. So let's look at the image. So I have a magnitude is 4. And then the counterclock is going to be that degree. So 60 is going to be here. So this is a 60 degree. And the magnitude of this is going to be 4. I want to find out this vector A, right? And then they say use the component form. So this is going to be anyway A1, A2, but I want to convert it to r times the cosine theta, r times the sine theta, correct? So everything is a given. This is the magnitude, but at the same time, this is the radius. Radius is a given 4, and then theta is a 60 degree. So let's plugging in. So the vector A is going to be 4 times cosine 60 degree, comma 4 times sine 60 degree. So if you go to the trigonometry table, cosine 60, that is going to be 1/2 as a radian. 4 times sine 60 is a radical 3/2. So therefore, cancel, cancel. You have a 2 comma radical 3. This is the component form. Okay, this is component form of vector A. So we got the answer. Okay. So, there are 2 ways you can describe this position as x comma y. Okay, or you can use the r comma theta component form of a vector. So they're indicating the same location. So likewise, I'm going to practice just 2 more like that. Let's go down slowly. Okay, find the component form. So r comma theta. So that means in terms of the vector A is going to be x comma y. We know r times cosine theta, r times sine theta. So that's the component form. And then here's the thing, magnitude is 4, angle is a negative 45 degree on the x-axis. So this is a negative 45. So many people forgot. If you go to counterclockwise, that's a positive angle. If you go to clockwise, that's a negative angle in trigonometry system. So therefore, we need to find out here. So we do have 45, negative 45 is going to be here, right? So this is negative 45. And then we are looking for this vector A as a component form. Okay, so we're going to represent X and Y in terms of the component form. So vector A is going to be R times cosine theta, R times sine theta. So R is for cosine negative 45 degree, 4 times sine negative 45 degree. And then just be aware, in the 4 different quadrants, in the first quadrant, all trigonometries are positive. Do you remember Osatanko? Second quadrant, only sine is positive. Quadrant third, tangents only positive. Quadrant 4, only what? Cosine is the positive. So no matter what you have negative, the outcome is going to be positive because it is on the 4th quadrant. This vector exists. Vector A exists on quadrant 4, where cosine, whatever the angle, is a positive, right? Therefore, you can find out simply cosine 45. Okay, so cosine 45 times 4, you can use a trigonometry table. So if you calculate it, or you can go to decimal, that's fine. So you can calculate it. It should be positive outcome, 2 radical 2. And then this is going to be negative. In the 4th quadrant, sine should be negative because only cosine is a positive. So if you calculate it, it's going to be negative 2 radical 2. So this is the component form of vector A. So we got it. So same question we are doing, right? So number 1, number 5, and 6, they're same work, okay? So let me give you one more example, just one more here before I'm gonna go to the application problem. So here is the question. So let me go here. So same thing, we're gonna find out the component vector A. So in this time, magnitude is a 6 and the degree is of 150. So let's draw the image. Where's a 150? Clockwise, so it's going to be the negative 150, right? So clockwise, we're going to the negative side. So negative 150 right there. And the magnitude, the radius is a 6. So if you feel like you don't want to work with the negative, so this angle, so negative 150 is the same location where 360 minus 150. So if you do that, 210, so positive, this is a positive 210 degree, and the bottom is a 150 degree. They're locating the same vector, correct? So you can use either minus 150 or positive 210 because they're indicating the same location right there, okay? So you can use a positive angle if you want. And first quadrant, all sine positive, tangent positive, and cosine positive in each different quadrant. So be aware of that. All right, let's find out the vector A in terms of the component form. So we are gonna convert it to R times cosine theta, R times sine theta. So R is a given 6. And now you are going to use, I want to use a positive angle instead of using negative. So cosine 210 degree, 6 times sine 210 degree. Again, you can go to the unit circle table that I show you in the last time video. So there's all the trigonometry table to find out the angle in terms of the radians. So 210 is going to be radical 3/2. But remember, this angle is on the third quadrant, so only tangents are positive. So we have a cosine. This one has to be negative outcome. Are you following? Because in the third quadrant, according to the, trigonometric concept, only tangent or cotangents are positive angle. So whatever the other angle should be negative. So cosine should be negative. So I'm gonna just adding, multiply negative. So therefore, that's the first part. Sine should be also negative. So 6 times 1/2, and you put the negative. Okay, be careful where the angle is located. So therefore, -3 radical 3, -3. This is the vector that they're indicating where in third quadrant. So this is component form of the magnitude 6 and degree 150. Okay, so you can do this work. So I show you 3 different examples in terms of the component form. So just keep in mind. Finally, yes, we're getting better. I'm gonna do a couple applicational problem where you're gonna see the vector in physics or engineering major. So those who are taking calculus 3, maybe you're, trying to go to, STEM major in 4-year college, after you transfer. So, this vector system, it's coming a lot in many engineer and physics major subject. So this question, maybe it's helpful. So let's take a look at the example of the application where you're gonna see the vectors. So here, let me change the color. So let me just write down the concept. Actually, I wrote for you. In physics, you see the force concept. So force is represented by a vector, okay? Since it has both magnitude and direction. So when you think of the concept of force, you're pushing or pull, and then where? Moving up or moving down, where you're pushing or where you're pulling. So this is the same concept as a vector because it has both magnitude and direction. And then there are several, force concepts. So if several forces are acting together, several forces are acting on specific object, there will be resultant force will be existed. And then how to find out the resultant force? You're gonna just adding all different forces summation. So in this example, we are going to calculate how to find out the resultant force by with the given different forces from many different directions. Okay, so let's take a look at the example. Here is the example. I'm going to give you guys 2 force F1 and F2. That means you have 2 different vector because the force you may be pulling or push to the specific direction. So this is the same as a vector you can consider. So force you can consider as a vector. So in this image, you have a force F1 and F2, and then force 1 has a 10-pound magnitude, that's their length, and then they're creating the angle 45 degree. And there's another force, magnitude is 12, and then the angle is going to be 30 degrees. So let's take a look at this image. I'm gonna create it. So force 1, this is a force 1. The magnitude is 10. That's what they're saying. And then they're creating the angle 45. Okay, so they are creating the angle 45. So you have to be careful. The force is always based on the x-axis. So this is x-axis. So the force 1 creating 45 degree, that means that this angle is a 45 degree. Because here, how are you going to create the 45? This is not going to be 45. So this is going to be 45 from the ground. Okay, 45 from the ground. And that means from the x-axis. So that's a 45 degree you can consider. So that's a force 1. Force 2, right there. The magnitude is 12, right? And then from the ground, they're creating exactly 30 degree. Everything is a given. They want you to find out the resultant force, which is a summation F1 and F2. So first, we need to evaluate F1 vector and F2 vector. So at the end, we're going to find out F resultant force, F1 plus F2, and then we're going to find out its magnitude and direction again. So are you following the concept so far? Okay, we good. So let's find out force 1 first. So let's find out force 1. Since they have a magnitude and degree, we're going to use a component form of the vector. So x comma y. We're going to convert it to r times cosine theta, r times sine theta as a component form. So r in the force 1 is a 10. And then be careful, you are not just using 45 degrees. So this location, okay, this means you are going to start from the beginning. So I'm going to use a red color. So 45, this location is the same as 45. So think about it. This 45, you begin from here to there. So this is actually negative 45. Am I correct? So whatever you're creating the angle, it's from the ground. So force 1 actually creating negative 45 because you're coming from the ground. So this is what? Clockwise negative degree. So negative 45 is the same as 180 minus 45, positive 135 degree. So instead of using negative angle, we're going to use a positive angle. So this is the angle you're looking for, right? This is the positive 135 from the, 0. So this is a positive angle. This is a negative angle. So therefore, cosine 135. Don't use a negative because always positive angle is better. So I'm going to write it one more time. You can think about this. If you cosine negative 45, 10 sine negative 45, instead of using negative, this is the same as 10 cosine positive 135, 10 sine 135, because a positive angle is better. So that's something you need to be aware. Convert to negative 45 to 135, because this is the location where, right? This is the location from, negative 45 or from positive 135. They're exactly located the same position. So I choose the positive angle. Okay, so we're going to calculate this. So that is 10 times. You can calculate cosine 135 in terms of the radian. Go to unit circle table. Okay, so go to unit circle table. So the cosine 135, it's going to be radical 2 over 2. 10 times the sine 135, it's also radical 2 over 2. But it's actually negative, my bad. So that you can calculate it. So you can find out because it's a negative, because in the second quadrant, so 135, so I'm going to write it. Angle 135 degree is located in the second quadrant where only sine angle is a positive. So therefore, you have a cosine, it should be negative there. Does it make sense? So therefore, we have a 10 negative radical 2 over 2, comma, sine anyway, positive outcome. So therefore, F1, we got it. Negative 5 radical 2, positive 5 radical 2. So that's your F1 vector. We got it. Okay, same thing. We're going to calculate F2. So F2, we have a radius 12. 12 times cosine 30. So this is no problem, exactly positive angle. 12 times sine 30. So once you calculate, 12 times cosine 30 is a radical 30 over 2, comma 12 times 1 over 2. So that would be 6 radical 3, 6. So this is a force 2 vector. Are you following? So we got F1 and F2. This is your F1, this is your F2. Now we are looking for the relevant, the resultant force, which is a summation. So F is going to be F1 plus F2. So F1, negative 5 radical 2, comma 5 radical 2, plus F2, 6 radical 3, 6. So if you're adding minus 5 radical 2 plus 6 radical 3, 5 radical 2 plus 6, this is your resultant force summation. And they actually looking for, I'm gonna make a little bit of space. They also ask you find out the magnitude and direction of the F. So we can calculate. The magnitude will be minus 5 radical 2 plus 6 radical 3 square, 5 radical 2, 6 square. You can use a decimal, that's okay. 13 over 13.5. That's the length of the resultant force, okay? So we got it, so far so good. Now what we are looking for, last one, magnitude and the direction. So we actually pretty much, direction it's going to be somewhere between. So I'm gonna actually copy this, if I can, copy. So we have here, so the summation, this is the summation. Oopsie. This is the force resultant. We found out this is the force F1 plus F2. Am I correct? So we know F1 and F2. So let me get rid of this. And then we know where's the force. We know that we found out the magnitude and we got what each F1, F2, F factor. Let me ask you, can you find out the last question? Can we find out the angle of resultant force? So I want to find out this length. So we know the angle of the resultant force is it's going to be greater than 30 degrees, which is, this is F2, but it's a smaller than 135 degree, F1. I want to find out this angle. You see what I'm saying? So think about it, a little bit of trigonometric concept. Here, F1, you can create a right triangle. Okay, you can create a right triangle. So to find out this angle, we are looking for the right triangle's angle. So here, I'm looking for this angle. This is the force, F1 plus F2, right? I want to find out this angle. So to find out that, we already know what the F, which is minus 5, what was it? Minus 5 over radical 2 plus 6 radical 3, comma, 5 radical 2 plus 6. This is the force location, which means this x unit minus 5 radical 2 plus 6 radical 3. And this is the y, 5 radical 2 plus 6. Are you following? So to find out the angle, we're going to use a tangent theta, because tangent theta is always y over x. So therefore, y, we already know 5 radical 2 plus 6. X, we know negative 5 radical 2, 6 radical 3. And then we are looking for the theta inverse. Inverse of that y over x. Does it make sense to you? So if you calculate it, and then you're going to change it to radian, we're going to change it to the just degree. That's how you're going to convert it to 180 over by multiplying 180 over pi. So you will find out 76 degrees. So you can actually, which is makes sense. This is a less than 90, greater than 30, and smaller than 135. So this is a 76 degree you can find out as well. So this is a more step up question. So definitely you can think about it. Okay. So that's the application problem where you are using all the vector concept. Okay, so same thing you could try. I have two more application problem. You can practice it, but let me just set up the equation for your better understanding. Okay, so in this question, let's take a look at quickly. So suppose that wind is blowing from the direction, so N 45 degree W implies that from north to the west, you're gonna create 45 degree. That's what they mean. And a speed is a 50. So we have a vector 1 right there. So if you draw the image, this is what? East, west, north, and south. So you have a vector 1, 45 degrees. So so we have a 45 from north to west. So this is the 45. So therefore, this is also 45. And then the magnitude is a 50, right? So the magnitude is a 50. Let's say this is a vector 1. Okay. So this is the first vector. I'm going to change this color. This is a vector 1. Second vector, from north to east, creating 60 degree. From north to east, so they're creating 60 degree. So this is going to be vector 2. So this is a 60, that is going to be 30 degree, correct? So they have a magnitude is much longer to 50. Okay, we're going to find out the resultant vector, true course, the summation. So you know how to do it, everything. You can find out, vector 1 and vector 2. So vector 1, 50 times, and then be careful. This is the 45 degree, negative 45, but this is the positive 45. You can start from here. So always from here. So this location is the same as 90 plus 45. So this is cosine 135 degree. Am I correct? So this location is actually indicating 135. And then 50 sine 135. So this is a vector 1. You're going to calculate it. Vector 2, what is it? 250 times cosine. This one is no problem. 30 degree, we're going to use it. 60 is not going to work, so we start from the ground. So 30, 250, sine 30. So you're going to evaluate each vector 1 and 2. Then to find out the total, that's a resultant vector, V1 and V2. Please do that. Once you find out the V1 and V2, that's the resultant vector. And then you can also find out the magnitude, correct? So the force is going to be somewhere here. We need to find out. So the two vectors, the summation will be somewhere. We don't know. So you can think about it. And then once you find out the magnitude, also find out the angle of a vector. Okay, you actually gonna get a very small angle. Okay, because in this time, the direction is everywhere. It's open everywhere. So what I'm saying is, vector 1 looks like this. Vector 2 looks like this. Okay. So the summation V1 and V2, you will find out somewhere here, okay? You will find out somewhere here, the V, okay? So practice this one. It's not really challenging question. You could do the same work, what I show you in Evolve. So once you find out the two V1 and V2, find out the summation. You can also find out the magnitude, also find out the, vector degree. Okay, so check this out. If you have any question, you can post in our discussion board. So this is the applicational problem you can think about, okay? And be careful, also tanko, you might have a negative angle as well. So check it out and then try the last one more time yourself. It's the same question, it should be fine, but you can think about first, okay? So that's all about 2.1. We just introduced concept of vector. There were a couple of terminology and there's a couple word you can think about. We're gonna continue to talk about vectors in the next video. I will stop recording and I will see you guys soon. Have a great day, guys. See you in the next video. Bye-bye.